When we do our research, we have basically three things in mind: create, measure, and understand. And those are all applied to charged polymers, polyelectrolytes. Charged polymers are water soluble, and they're found in many commercial and consumer items such as shampoos, personal care products, and also in many industrial chemicals. We do a mixture of applied and fundamental science because that is the best balance of approaches to create the most lasting impact on the field and to create the best graduate student for the job market. Our current projects, we have two very different kinds of projects. Well, the first kind, supported by the National Science Foundation, is to understand and predict the properties of these polyelectrolyte complexes. So we have different mixtures of polymers that we blend together. If we don't have the polymer, if we don't find it commercially available, we go out and make it. And then we do very high-level measurements on these materials. And it's important for my students to do measurements that are really the state-of-the-art measurements. These are light scattering, for example, neutron scattering, rheology, because these are the measurements that are looked on by industry and academia and all polymer science as the sort of pinnacle of your abilities to make measurements on polymers. That's the fundamental side. And then the applied side, we have a grant from the Navy, and we've developed a new set of polymers that prevents the fouling of ship hulls by organisms. And you can imagine that this is a headache for every single thing that goes into seawater. It collects a whole bunch of critters, they grow, and after a while, you've got this big mess. It slows you down, and in fact, it costs an enormous amount in terms of lost efficiency of propulsion and therefore lost energy. So we're kind of contributing to reducing energy use throughout the world by producing a coating that prevents barnacles, algae, bacteria, seagrasses from sticking to boat hulls. When you work in materials, and polymer specifically, you acquire quite a broad palette of skills. The skills are in designing experiments, which is a really important skill you'll learn. Another skill is to ask the right questions. And another skill is to ask meaningful questions, because you have the ability in the lab to answer an unlimited amount of questions, but your time is limited. So you have to prioritize and figure out which one of those scientific questions is the most meaningful, that will make the most difference. Let's find the most interesting problem we can tackle and go for that.